Okay, this is still 10-2, part 2. And on this one, the center of a regular polygon is equidistant from the vertices. The apothem is the distance from the center to a side. A central angle of a regular polygon, we've already talked about central angles, has its vertex at the center and its sides pass through the consecutive vertices. Each central angle measures of a regular entagon is 360 degrees divided by n. Okay, so what we have here is we have the center of a regular polygon, that's point C here. The apothem is an endpoint at the center and the endpoint at the side, and it bisects this segment right here, okay? So this right here, CB, is the apothem. And then your FC, CE, CD, those are all congruent. And then your central angle would be this right here. So to find the measure of a central angle of a regular polygon, you would use this formula. Okay, so the area of a regular polygon is where you take half of the apothem, A is the apothem, times capital P, the perimeter of that regular polygon. So let's look at this. Okay, find the area of this heptagon. All right, so let's make our center. And this right here down the middle is your apothem, the dotted line, perpendicular to the base there. Let's see, each side length is 2 feet. So each side length is 2 feet. And we are trying to find the area of this regular heptagon. Okay, well first let's find the perimeter. The perimeter is where we take 2. A heptagon has 7 sides. All right, then we need the apothem. Well, this measure here is 2. The apothem bisects this. So this here is 1 and this here is 1. Okay? Now, what we need to find is the measure of this central angle right here. So, to find the central angle, you take 360, divide by 7. That's going to give you the central angle measure of, it's going to be approximately 51. Okay. So that's what the central angle measurement is. So I'm going to redraw this triangle so y'all can see it. Here's my apothem. This segment here is 1. This angle here is half of the 51. So 51.4 divided by 2. And that's going to give me, what is that, 25.7? 25.7 degrees. Okay, and we need to find the apothem, so I can use my trig ratios. I have opposite adjacent, so I can take the tangent of 25.7 degrees and put that equal to opposite over adjacent. Got to get rid of that denominator A there, so I'm going to multiply both sides by A. And then I'm going to divide by the tangent. So A equals 1 divided by the tangent of 25.7 degrees. Okay, do not find that answer yet. To be as precise as possible, this is what you're going to key in your calculator. Okay, so the area is 1/2. Your apothem is 1 divided by the tangent of 25.7. times the perimeter, which is 14. And that's what you need to key in your calculator. And once you do that, you should get approximately 14.5 feet squared. do another one. All right, find the area of a regular dodecagon with the side length of 5. Okay, so our side lengths are 5. Here's the center. There's the apothem. Here's the smaller triangle. Here's the apothem. Half of 5 is 2.5. Okay, so area equals half of the apothem times the perimeter. Well, the perimeter is 5 times 12, which is 60 centimeters. Okay, we got to find that central angle. Central angle equals 360 divided by 12, and you get 30 degrees. Okay, so what that means is this angle here is 15 degrees. So to find the apothem, you take the tangent of 15 degrees and put opposite over the apothem. Cancel out the A, divide by tangent of 15. So your apothem is going to equal 2.5 over tangent of 15 degrees. Okay, so in your calculator, you have 1/2 the apothem times the perimeter, and you should get approximately 279.9 centimeters squared. Okay. Last one. I'm going to be quiet. Let y'all do this one on your own. That's it, guys. Have a good evening.